Let's look at transforming some cosine functions now. Remember, it's always going to be helpful to rewrite the function in the standard form, y equals a cosine b times the quantity x minus c plus d, because being able to identify each of the constants, a, b, c, and d, is going to help us in determining each transformation. Remember, a determines the amplitude. Those are our vertical stretches and shrinks. How do we find amplitude? It's the absolute value of a. Or if we have a graph, we take the maximum value minus the minimum value divided by 2. B influences the period. Those are our horizontal stretches and shrinks. To find the period, we take 2 pi and divide by the absolute value of B. C, those are our phase shifts. Determining C will determine how our function is shifted horizontally. And D, those are our vertical shifts. Vertical shifts up, vertical shifts down. So let's go. Look at a cosine function. F of x is equal to 4 cosine x minus pi plus 2. Again, always good to remember the standard form, y equals a cosine b times the quantity x minus c plus d. The nice part about this problem, it's already written out in standard form, so we can easily identify each constant. What's the amplitude? Well, amplitude is the absolute value of the a constant. The absolute value of 4 is 4. Period. To find the period of our function, we take 2 pi and divide by the b constant. Now, remember that b is the constant multiple that's in front of the x, and in front of this x right here, we actually have a 1. It is implied that there's a 1 in front of the x, therefore the period is 2 pi divided by 1, which just leaves us with 2 pi. Next, our phase shift. Our phase shift is equal to our value c. Remember, this is the form x minus c. Here I have an x minus pi. Therefore, c is equal to pi. We have a phase shift of pi units to the right. And are there any other transformations that we have from our parent function? Yes, we have this plus 2, this d constant on the end, for a vertical shift up 2 units. So let's begin to now sketch our graph. Always want to start with the shape of our parent function. And remember that the cosine of 0 is equal to 1. The y-intercept of our cosine function is 1. Okay, there's our parent function. We want to go in the order, scalings first, then reflect, and then shift. So we clear out our x-axes and start with a fresh graph. All right. First, A, amplitude. That's our vertical scaling. If we have an amplitude of 4, that means that our wave has to travel 4 units above the midline, and it has to travel 4 units below the midline. Now we have an amplitude of 4. We did our vertical scaling. Let's look at our horizontal scaling. That's our period. How long does it take for the function to repeat itself? Well, that's how long it takes for me to get from one maximum value to the next maximum value. That means that this hash mark right here, I can put in as 2 pi. And if I go the opposite direction, this one right here has to be a negative 2 pi. And I've continued to keep quarter period tick marks in here, meaning that each one of these tick marks will correspond to a half a pi. A half a pi, a full pi, a 3/2 a pi, 2 pi, negative a half pi, negative 1 pi, negative 3/2 pi, negative 2 pi. Okay, we did our vertical scalings and we did our horizontal scalings. After we scale, we want to reflect. There are no reflections in this case, so we can move on to our shifts. Let's do our horizontal shift first. And again, we're just going in order A, B, C, and then D. So our phase shift is going to be pi. Every single point on this function is going to move to the right pi units. That means that this minimum value will move to 2 pi. That means that this maximum value will move to pi. This minimum value will move to 0. Right? Shifting every single point on this graph pi units. And then finally, our vertical shift, we want to shift everything on the graph up 2 units. So if we shift every single point on this graph up 2 units, the maximum values are now going to be at 6, and the minimum values are going to be at negative 2. There we have it, the shape of our function f of x equals 4 cosine x minus pi plus 2. What's the domain of our function? Well, as we have said, the domain of every single sine and cosine function is always going to be all real numbers. And the range of our function, well, our lowest y value is -2. Our greatest y value is 6. Therefore, our range is -2 to 6, being closed intervals, brackets on the outside, because those endpoints are included. Okay, let's take a look at one more cosine function. F of x equals -2 cosine pi over 2x plus pi over 2 minus 1. Remember, always going to be helpful to write this in the standard form, y equals a cosine b times the quantity x minus c plus d. Well, here in this case, anytime you have a period change and a phase shift occurring at the same time, we're going to want to factor out that b constant from each term inside of the parentheses. Okay, if I factor out a pi over 2 from each one of these, that leaves me with -2 cosine pi over 2 times x plus 1. If you're wondering how we got the x plus 1, remember that when you're factoring out a quantity, you're just dividing it out from each term. If I take pi over 2 times x and divide it by pi over 2, that leaves me with a 1x. And if I take pi over 2 and divide by pi over 2, I get a 1. And again, notice that distributing that back in would bring me back up to the initial equation that we started with right here, right? Pi over 2x plus pi over 2. Okay, so now that we've written it in the standard form, we can easily identify the constants a, b, c, and d, which will tell us our transformations. What is our amplitude? Well, amplitude is the absolute value of a. The absolute value of -2 is 2. That means that our function will go 2 units above the midline and 2 units below the midline. Period. To calculate period, we take 2 pi and divide by the b constant. This would be 2 pi divided by pi over 2. Dividing by pi over 2, well, that's the same as multiplying by 2 divided by pi. Notice that your pi's will cancel out and you will be left with 4 as a period. This function will repeat itself every 4 units. Our phase shift, that is determined by the constant c. Remember, it's x minus c. Here I have an x plus 1. If I'm going to get a plus 1, that means that c has to be -1. I have a phase shift of 1 unit to the left, a phase shift of -1. And do we have any other transformations? Well, notice that a is negative. That gives us a reflection in the x-axis. And we have a d constant of -1 that corresponds to a vertical shift down 1 unit. So, to sketch our graph, we always start off with the shape of our parent function. Here's the graph of y equals the cosine of x. And remember, the order we want to go in is scale, reflect, and then shift. So, we draw out our wave, clear out our axes, and now we can begin a fresh start with our vertical scalings and our amplitude. So if this has an amplitude of 2, that means our graph has to travel 2 units above the midline. We can label that as a 2, and 2 units below the midline, -2. We have a period of 4. That means it repeats itself every 4 units. So the distance from one maximum to the next maximum, that's going to be 4. And I can do the same going to the left. This would be -4. And again, notice my quarter period increments. These are going to correspond, in this case, to 1 unit marks. So I have 1, 2, 3, 4, -1, -2, -3, and -4 going to the left. All right? Not too bad when they come out as whole numbers here, integers. It's really nice. All right. So we did our vertical scaling, we did our horizontal scaling. Next, we need to do our reflections. We have a reflection in the x-axis. That means every single maximum is going to become a minimum. Every single minimum is going to become a maximum. Take that graph and flip it over the x-axis. Okay, there's our reflection, and now we can begin to do our shifts. Let's start with the phase shift. That's our c constant. Well, every single one of these points is going to move to the left 1 unit. So this minimum, which was at x equals 0, is going to move to x equals -1. This maximum that was at x equals negative 2, that's going to move to negative 3. This maximum that was at 2, that's going to move to 1. Every single point is getting shifted to the left 1 unit. All right, and then finally, we have to do a vertical shift down 1 unit, meaning that every single one of these points on our graph is going to shift downward. That means our maximums, instead of occurring at 2, are going to occur at 1, and our minimums, instead of occurring at negative 2, will occur at negative 3. Right? And there we have the shape of our graph. F of x equals negative 2 cosine pi over 2x plus pi over 2 minus 1. What's the domain of this function? Well, domain is still all real numbers. And our range in this case, our lowest y values are negative 3. Our highest y values are 1. Therefore, our range is negative 3 to 1 with brackets. They are included. All right, those are your transformations for your cosine function.